If you're a developer, you know this feeling all too well. Your code works like a charm on your machine, but the second it hits production, it just shatters. Well, today, we're going to fix that. We're going to dive in and master the local Kubernetes setup. I mean, we've all been there. You've got this new feature, it's running flawlessly on your laptop, you ship it, and then total chaos. It's one of the most common and, let's be honest, most frustrating parts of our job, and that's exactly what we're tackling head-on today. So this problem actually has a name. It's called the fidelity gap. And really, it's just the massive difference between your simple, cozy local setup and the complex, chaotic reality of a production Kubernetes cluster. Think about it. Maybe your app works fine locally because it has your whole machine to itself, but in production, it just falls over without the right CPU limits. Or maybe it breaks because it can't find a Kubernetes secret that you never even thought to include in your local test. This gap, this is where the nastiest bugs love to hide. So, the big question is, how do we close that gap? Well, that's our mission for today. We're going to figure out how to create a local setup that's a true mirror of production. The goal? To let you build and ship your code with some real confidence. You know, back in the day, it was so much simpler. A local web server, a database on your machine, and you were pretty much good to go. But now, with Kubernetes orchestrating these massive, complex applications, yeah, that world is gone. Your laptop basically needs to become a miniature cloud. It has to simulate containers, tricky networking rules, config maps, secrets, the whole shebang. Okay, so that brings us to our first big decision, choosing your local cluster tool. And this isn't just a matter of preference, it's a critical choice. The tool you pick is going to determine just how well you can mimic production and honestly, how fast and efficiently you can get your job done. When you really boil it down, the choice comes down to one fundamental trade-off. On one side, you've got heavy virtualization. We're talking VMs. This gives you total OS isolation, like having a completely separate server, but man, it will eat up your system resources. On the other side, you've got lightweight containerization. This approach shares your machine's OS kernel, which makes it super fast and really, really lean. So let's start with the veteran of the space, Minikube. This is the old guard, the most mature, feature-rich tool out there. It's got this cool driver model, which gives you options. You can run it inside a full-on VM for that maximum isolation we talked about, or you can run it inside a Docker container to get a little more performance. Honestly, it's the gold standard if you want a complete environment with all the bells and whistles, like the Kubernetes dashboard or an ingress controller, ready to go right out of the box. All right, next up is Kind, and that literally stands for Kubernetes in Docker. And its approach is just so clever and powerful. Here's the deal. It runs each Kubernetes node as a simple Docker container. That's right, the control plane, all your worker nodes, everything is just a container. This design makes startup times just ridiculously fast. But the real superpower here, it makes simulating a realistic multi-node production environment incredibly, incredibly simple. Now, what if performance and efficiency are your absolute top priorities? Well, then you need to meet K3s. This is a super lightweight, fully certified Kubernetes distribution. We're talking the smallest footprint of them all. It's usually managed by a tool called K3D, and it does some really smart things like stripping out non-essential features and swapping the standard database with SQLite for single-node setups. It is the perfect choice if you're on an older machine or for anyone who just needs to squeeze every last drop of performance out of their hardware. And of course, we have to talk about Docker Desktop. It comes with a single node Kubernetes cluster that you can literally enable with one checkbox. It's the easy button. And that simplicity is fantastic if you're just running your very first container on Kubernetes. But, and it's a big but, that convenience comes with a major trade-off. You get very little configurability, and it's stuck as a single node, which, let's be honest, doesn't really look like most production setups. Okay, so this table really brings it all together, right? Let's look at the multi-node support row. See that? Kind and K3s have native support, which is absolutely critical if you need to test how your app behaves in a distributed system. Now let's jump over to the resource usage row. K3s is the clear winner here if you're trying to be efficient. For just general learning and playing with lots of add-ons, Minikube is probably your best bet. And Docker Desktop? Great for that first quick simple test. So use this as your cheat sheet for picking the right tool for your job. All right, so you've picked your tool, your cluster is up and running. Now what? Now you need a way to actually pilot this thing. And that is where kubectl comes in. I want you to think of it as the universal cockpit for any Kubernetes cluster, no matter how you built it. Okay, listen up, because before you type a single command, you have to know about the version skew policy. This is so critical. Your kubectl client has to be within one minor version of your cluster's server. So a 130 client can talk to a 129, a 130, or a 131 server, and that's it. Trust me on this, if you get this wrong, you are going to spend hours chasing down the weirdest, most impossible to debug API errors. Just save yourself the headache. So how does kubecontrol magically know which cluster to talk to? It all comes down to a file called the kubeconfig file. The best way to think of it is as the address book for all of your clusters. I mean, as you work, you're going to have your local dev cluster, maybe a team staging cluster, maybe even access to production. This one simple YAML file holds all the info kubecontrol needs to find and talk to every single one of them. So let's break that file down. The first key section you'll see is clusters. This part is all about the where. Each entry in here defines the URL for a cluster's API server and, importantly, its certificate authority. That's how your client can verify it's talking to the right server. So really, this section answers the question, where is the cluster and can I trust it? Okay, next up is the users section. And you guessed it, this defines the who. This section holds the credentials for a client. And for our local clusters, that's usually just a certificate and a private key. This is how the cluster authenticates you and figures out what you're allowed to do. And finally, we get to the most important piece of the puzzle, contexts. A context is the glue that holds it all together. It's just a named shortcut that links a specific user to a specific cluster. This is the magic that lets you type one simple command and instantly switch from controlling your local dev box to the team staging environment. It's what makes working with multiple clusters manageable. All right, that's enough theory. Let's get our hands dirty. It's time to actually spin up a cluster from scratch. So if you decided to go with Minikube, a command like this one is your new best friend. Let's walk through it. We're telling it to use the Docker driver, which is usually a good bet for performance. We're also giving it a unique profile name, dev cluster, which is awesome because it lets you run multiple, totally separate Minikube clusters at the same time. And this last part is crucial. We're setting memory and CPU limits right from the start to make sure it doesn't just hog all our resources and slow our laptop to a crawl. And check out how simple it is with Kind to create a realistic multi-node cluster. It's just 3 steps. First, you create a tiny little YAML config file. Second, you define the roles you want, say 1 control plane node and 2 worker nodes. Then you just run 1 command pointing to that file. That's it. In less than a minute, you have a fully functional multi-node cluster all set to test your distributed apps. It's amazing. Okay, so your cluster is up, it's running, you're feeling good. But now you're about to run smack into the first big, hairy workflow challenge that every single developer hits. And here it is. You run Docker build on your laptop, you create a brand new image, and that image lives in your local machine's Docker daemon. The problem? Your Kubernetes cluster is often its own little isolated world, a VM or a container, and it has no idea that image even exists. It can't see it. So, how do you get your image from here to there? Well, there are basically 2 common ways to solve this. With Minikube, you can run a special command that essentially points your Docker client to the Docker daemon that's running inside the Minikube cluster itself. Then you just build your images directly there. The workflow for Kind is a little different. You build the image on your host machine, just like you normally would, and then you use the Kind load command to efficiently push a copy of that image into all the nodes of your cluster. Now, this right here is the final, absolutely critical piece of that puzzle. Inside your Kubernetes deployment YAML, you have to tell your pods how to find that image you just loaded. By setting the image pull policy to if not present, you're basically telling Kubernetes, hey, before you go looking on the internet, check for this image locally inside the cluster first. Only if you can't find it there should you try to pull it from a remote registry. This is what forces it to use the local image you just built. Okay, so to wrap things up, let's go over a few essential habits for making local Kubernetes development work for you. First, always set resource requests and limits in your manifests. This isn't just good practice for production, it's what's going to protect your own machine from a runaway process. Second, to actually access your running app, you'll need to use a service of type node port or a tool like Minikube Tunnel, because those fancy cloud-style load balancers just aren't available locally. And third, get comfortable with kubectl. Mastering it, along with your kubeconfig and maybe a context switcher like kubetex, is the real key to working quickly and efficiently across all your different clusters. So there you have it. You now have the roadmap to build a local Kubernetes environment that's a true high-fidelity mirror of production. And look, this isn't just about squashing bugs earlier. This is about giving you the power and the confidence to experiment, to innovate, and to ship better software faster than ever before. You've got this incredibly powerful sandbox right at your fingertips now. So the only question left is, What are you going to build first?